Close your eyes for just a moment and think about yesterday. It feels like it is gone forever. Now think about tomorrow. It feels like it hasn't arrived yet. And between those two lies what we call the present, a tiny instant that seems to move endlessly from the past into the future. Every second, another moment disappears, replaced by a new one. This experience feels so natural that we rarely stop to question it. But what if this familiar feeling is not telling us the full story? What if the sensation of time flowing is something created inside your mind rather than a feature of the universe itself? Imagine watching a train pass by your window. One carriage appears, then another, then another. To you, each carriage exists only when it comes into view. But someone standing high above on a nearby hill can see the entire train at once. They are not watching each carriage appear and disappear. They simply see the whole train stretched across the tracks. Neither observer is wrong. They are simply seeing the same reality from different perspectives. Our experience of time may be surprisingly similar. Every memory you have tells your brain that time moves in one direction. You remember your childhood, but not your future. You remember breakfast, but not tomorrow's dinner. This creates a powerful impression that the past has vanished while the future does not yet exist. Yet notice something interesting. This conclusion comes entirely from the way your brain stores information. Your memories point backward, not because the universe necessarily does, but because your brain records events after they happen. Think of reading a novel. As you turn each page, the story unfolds chapter by chapter. The characters experience surprises because they don't know what comes next, but the entire book already exists in your hands. The last chapter is printed just as permanently as the first. The feeling of discovery belongs to the reader, not to the paper. Could our lives be something like that? Every second, your brain receives signals from your eyes, ears, skin, and countless other senses. It organizes these signals into what feels like a continuous moving present. Neuroscientists have discovered that the brain even delays incoming information by tiny fractions of a second so it can combine everything into one smooth experience. In other words, what you call now is already a carefully constructed picture assembled inside your mind. That realization is astonishing. The present may not be a razor-thin line sweeping through the universe. Instead, it may be the way your brain makes sense of an unimaginably complex reality. This raises a question that has fascinated scientists and philosophers for generations. If the feeling of time flowing comes from the way we experience the world, does time itself actually flow at all? Or is the universe very different from the story our senses tell us every day? These questions are not science fiction, and they are not merely philosophical games. They lead directly to one of the greatest revolutions in physics, a revolution that completely changed how scientists think about space, time, and reality itself. To understand why some physicists say death may be very different from what we imagine, we first have to let go of the comforting assumption that time behaves exactly as it feels. Once that assumption begins to crack, an entirely new picture of the universe starts to emerge, one that is stranger, deeper, and far more beautiful than our everyday experience suggests. For thousands of years, people believed that time was the one thing everyone shared equally. It didn't matter whether you were standing still, sailing across an ocean, or racing through the sky. A second was a second, and the entire universe was thought to march forward together like a perfectly synchronized orchestra. It was such an obvious idea that almost no one questioned it. Then, in the early 20th century, that certainty was shattered. Imagine two friends carrying identical clocks. One stays on Earth while the other boards a spacecraft traveling at an enormous speed. When they reunite, something remarkable has happened. The clocks no longer agree. The traveler has experienced slightly less time than the friend who remained behind. This isn't because the clock malfunctioned. In fact, every process inside the spacecraft, including the traveler's heartbeat, thoughts, and biological aging, also slowed relative to the observer on Earth. Time itself unfolded differently. At first, this sounds impossible. How can time, something we think of as universal, depend on motion? The answer begins with a surprising discovery. The speed of light is always the same for every observer, no matter how fast they are moving. To preserve this constant speed, the universe makes unexpected adjustments. Distances can shrink and time can stretch. These effects are not tricks of perception. They are woven into the laws of nature and have been confirmed repeatedly through experiments. Modern technology quietly depends on this fact every day. Satellites orbiting Earth carry extremely precise atomic clocks. Because they are moving rapidly and are farther from Earth's gravity than clocks on the ground, they experience time at slightly different rates. Engineers must constantly correct for these differences. Without those corrections, navigation systems would accumulate large errors, making GPS increasingly inaccurate. The phone in your pocket works because the universe behaves exactly as relativity predicts. Motion is only part of the story. Gravity also changes time. Picture two identical clocks once again. Place one at sea level and the other on top of a very tall mountain. The clock higher up, where gravity is slightly weaker, will tick just a tiny bit faster. The difference is incredibly small, but sensitive instruments can measure it. Gravity is not simply a force pulling objects together. According to relativity, massive objects bend the fabric of space-time itself, and that curvature changes how time passes. This leads to an even deeper realization. Space and time are not separate ingredients of reality. They are woven together into a single four-dimensional fabric called space-time. Every event, every sunrise, every conversation, every heartbeat has both a position in space and a position in time. You cannot fully describe where something happens without also describing when it happens. One of the most surprising consequences is that there is no single universal now. Imagine two lightning bolts striking opposite ends of a moving train. An observer standing on the platform may judge the strikes to occur at exactly the same moment, but someone riding inside the moving train can conclude that one strike happened before the other. Neither observer is making a mistake. Both measurements are correct within their own frame of reference. The order of some distant events can depend on the observer's motion. This idea challenges one of our deepest intuitions. We naturally imagine that the entire universe shares the same present moment. Relativity tells us that nature is under no obligation to organize itself that way. What feels like a shared now is not a universal feature written into the cosmos. Instead, each observer carries their own perspective through space-time. Once you accept that time is flexible, intertwined with space, and experienced differently depending on motion and gravity, an even more extraordinary question begins to emerge. If there is no universal present slicing the universe into past and future, then what exactly are those categories? That question opens the door to one of the most fascinating interpretations of relativity, one that invites us to rethink not only time itself, but the meaning of a beginning, an ending, and perhaps even death. Now comes the idea that surprises almost everyone the first time they hear it. If there is no single universal now, then perhaps the universe is not continuously creating one present moment after another. Perhaps our experience of moving through time is only one way of looking at something much larger. This is where the concept often called the block universe enters the conversation. Imagine opening a photo album filled with pictures from every stage of your life. One photograph shows your first day of school, another captures a birthday celebration, another shows a family vacation. The final pages contain moments that happened only recently. As you flip through the album, each picture appears one at a time. But notice something important. The photographs are not being created as you turn the pages. They are all already there. Your experience of seeing them one after another does not determine whether they exist. Now replace the photo album with your entire life. According to the block universe interpretation, every event in your life occupies its own place within space-time. Your first breath, your first conversation, your happiest memory, and this very moment are all part of the same four-dimensional structure. They are connected like points along a path known in physics as a worldline. Instead of imagining your life as a moving dot traveling through time, this view imagines your entire history as one complete path extending through space-time. A useful way to picture this is to think about a movie stored on a reel. Inside the reel are thousands of individual frames. If you watch the movie in a theater, the projector displays only one frame at a time. To the audience, the story unfolds second by second. Characters seem to move, grow older, and experience events in sequence. But someone holding the entire film reel can see that every frame already exists. The beginning, the middle, and the ending are all physically present on the reel, even though the audience experiences them one after another. Our experience of time may resemble the audience watching the film rather than the person holding the reel. Some physicists have suggested that space-time can be understood in a similar way. Every event has its own location within the four-dimensional universe. Nothing needs to pop into existence and then vanish forever. Instead, each moment simply occupies its own position, just as every city occupies its own location on a map. You would never ask where Paris goes when you travel to Rome. Paris has not disappeared. You are simply no longer there. In the same way, one interpretation suggests that moments in time do not cease to exist simply because your experience has moved on. This perspective changes how some people think about endings. Instead of imagining life as a line that is constantly erased behind you, the block universe pictures your entire world line as a complete geometric object within space-time. Every joyful moment, every challenge, every discovery remains part of that structure. From this viewpoint, reaching the end of a life is not the same as deleting everything that came before. The earlier moments continue to occupy their places within the fabric of space-time. It is important, however, to keep science separate from speculation. The block universe is an interpretation inspired by Einstein's theory of relativity and by the absence of a universal present. It offers a powerful way to visualize space-time, but it is not an experimentally proven description of reality. Scientists continue to debate the true nature of time, and other interpretations exist alongside it. Even so, the idea invites an extraordinary shift in perspective. It suggests that what we call the past may not simply be a collection of vanished moments. Instead, those moments could be enduring parts of the universe's structure, woven permanently into space-time itself. If that possibility is even partly true, then the familiar picture of life as something that appears briefly and disappears forever may be far too simple. And that naturally leads to the biggest question of all. If our moments occupy lasting places in space-time, what does relativity actually say about death? And just as importantly, what does it not say? At this point, it is tempting to make a giant leap. If space-time may contain every moment of a person's life, then does that mean death is an illusion? Does relativity prove that we never truly die? These are fascinating questions, but this is exactly where careful science becomes essential. The most exciting ideas are often the ones that demand the greatest discipline. Relativity transformed our understanding of time, but it did not erase the biological reality of death. When a person's body can no longer sustain the processes that keep it alive, their heart stops, their brain ceases to function, and consciousness, as far as current scientific evidence can tell, comes to an end. Einstein's equations do not predict that awareness continues after this point, nor do they provide evidence for an afterlife. Those are questions that lie outside what relativity itself can answer. So why do people sometimes say that relativity changes the meaning of death? The answer lies in the distinction between events and experience. Relativity describes the geometry of space-time. It tells us how events are arranged, how clocks behave, and how different observers measure time. It does not tell us what consciousness is or whether it can exist independently of a living brain. These are entirely different scientific questions. Imagine standing in front of a giant world map. Every city is marked on its surface. Tokyo, Cairo, Rio de Janeiro, and Sydney all exist on the map at the same time. If you travel from one city to another, the city you left behind has not vanished. It still occupies its place. Your journey changes your location, not the existence of the places themselves. The block universe uses a similar picture. Every event along your life's world line occupies its own location in space-time. Your 10th birthday, your graduation, today's conversation, and the final day of your life all belong to that geometric structure. From this perspective, reaching the end of your world line does not erase the earlier events. They remain part of space-time in the same way that every location remains part of Earth's geography. But notice what this analogy does not say. It does not mean that a person at one point on the map is simultaneously conscious at every other point. A photograph from your childhood still exists today, but the child inside that photograph is not actively experiencing the present moment. In the same way, saying that events have locations within space-time is not the same as saying awareness exists everywhere along that timeline at once. This distinction is incredibly important because popular discussions often blur the line between physics and philosophy. A scientific theory can inspire philosophical ideas without proving them. Relativity provides a mathematical description of space and time that has survived more than a century of experimental testing. The claim that consciousness somehow escapes death because of relativity is a separate idea, one that has not been demonstrated by scientific evidence. And yet, even without making claims it cannot support, relativity still offers something profound. It invites us to see life differently. Instead of imagining every meaningful moment being swallowed forever by the passing of time, it suggests a universe where those moments belong to the permanent structure of space-time itself. Every smile, every act of kindness, every discovery, every conversation becomes part of the history of the cosmos. Perhaps that is why this idea continues to fascinate scientists, philosophers, and ordinary people alike. It does not promise immortality, nor does it solve the mystery of consciousness. What it does offer is a humbling reminder that the universe may be stranger than our everyday intuition allows. Death, according to relativity, is not explained away, but our picture of time, and therefore our picture of what it means for a life to have existed, may be far richer than we ever imagined. After exploring how relativity reshapes our understanding of time, one thing becomes clear: the universe is under no obligation to match our everyday intuition. We wake each morning believing that the past is gone, the future has not yet arrived, and only the present is real. That picture feels obvious because it is how our minds experience reality. But science has shown us, again and again, that reality often lies beneath appearances. The Earth feels perfectly still, yet it spins at tremendous speed. Solid objects seem motionless, yet they are built from restless atoms. Time itself feels like a flowing river, yet relativity suggests that this familiar feeling may not tell the whole story. Whether or not the block universe is ultimately the correct description of reality, it encourages us to ask better questions. Instead of asking, "Where did yesterday go?" we might ask, "What if yesterday is not something that had to go anywhere?" Instead of imagining life as a candle that burns until nothing remains, we can imagine it as a complete story woven into the fabric of space-time. Every chapter has its place. The first page is no less real because you are currently reading the last. Think about a mountain trail. A hiker standing near the summit can look back and see the winding path stretching through forests, rivers, and valleys. Every section of the trail still exists, even though the hiker is no longer standing on it. The beginning has not disappeared, it simply occupies a different place. If our lives resemble a path through space-time, then every moment we have ever lived remains part of that journey's shape. The laughter of childhood, the mistakes that taught us wisdom, the friendships that changed us forever, and the quiet moments no one else remembers all contribute to the unique path that only we could trace. This perspective can quietly change the way we think about meaning. We often worry that moments vanish the instant they pass. We chase time because we imagine it slipping through our fingers forever. But if each event belongs permanently to the history of the universe, then every act of kindness, every lesson learned, every word of encouragement, and every expression of love becomes an enduring part of reality's structure. They are not erased simply because the clock keeps ticking. That does not mean we should stop valuing the present. In fact, it suggests the opposite. Every choice we make becomes another point along our world line. Every decision shapes the story that is forever written into space-time. The present is precious not because it is the only thing that exists, but because it is where our actions become part of the universe's history. Science also teaches humility. There is still much we do not know about time, consciousness, and the deepest nature of reality. Physicists continue to explore competing ideas. New discoveries may refine today's understanding or even replace parts of it with something more complete. That willingness to question even our most cherished assumptions is one of science's greatest strengths. It reminds us that certainty is not the goal. Understanding is. Perhaps the greatest lesson hidden inside relativity is not that death is a misunderstanding, but that our assumptions about existence are often far smaller than reality itself. The universe is vast enough to challenge common sense, patient enough to reveal its secrets one discovery at a time, and mysterious enough to leave room for wonder even after centuries of scientific progress. So the next time you look at an old photograph or remember a moment that changed your life, consider it from a different perspective. Perhaps that moment is not simply a fading memory trapped inside your mind. Perhaps it is also a permanent event in the grand architecture of space-time, a place that will always belong to the universe. Relativity does not promise that we escape death, and it does not answer every mystery about existence. But it does offer something remarkably beautiful, the possibility that a life once lived is forever part of the cosmos, woven into its history with a permanence far greater than our everyday experience of passing time ever suggests.